Specifically, we will see what happens when there is a dependent source. Okay, let us take an example. Let us take an example. You can also take a pen and paper and try to solve this. Okay, what we are doing, we are taking a voltage source plus minus. It is a independent voltage source that is of, let us say, 2 volt. Then there is a resistance that is of 2 ohm. Then there is another resistance which is of 1 ohm. Okay, now there is a dependent source. This diamond like sign, that means it's a dependent source. Now what it is dependent on, again minus plus is there, so it is a dependent voltage source, and just beside it, it is written that 2 of Vx, and Vx is denoted like this, minus plus Vx. So it is a voltage controlled voltage source. Okay, so this dependent source is there, and there is this resistance value of 1 ohm. Then there is another resistance of 1 ohm. And there is a current source of 2 ampere. Now what you have to find, the question is use superposition theorem to find, let us say this is the current I, okay, current IB, let us say, to find the current IB. Okay. So how will you try this? Okay. So we are first seeing an example where how to apply superposition theorem when there is a dependent source. Okay, so dependent source problems are very important. I'm not able to see. How will you solve this? Now superposition theorem, that means you have to take these sources one by one. Okay, so considering the voltage source first, considering voltage source only, that is independent voltage source, considering independent voltage source, then you have to deactivate the current source. You have to deactivate the current source. Deactivating current source means replacing it with its internal resistance, ideal internal resistance. So for a current source, the ideal internal resistance is infinite. So you can replace this with a open circuit, replace this current source with a open circuit. So your circuit will look like this. Oh, there was a resistance here. There was a resistance here that I missed. That means you have to find what is the current here. This is IB. This IB is nothing but what is the current flowing through this loop. Okay. So if you consider the current I is flowing through this loop, then that current you have to find out. Okay. So if you apply KVL here, let us consider some current I is flowing, then you apply KVL. Okay, forget about this plus minus Vx for now. So to apply KVL, you need the plus minus sign. So the current is flowing in this direction. So this will be plus, this will be minus. Current will flow from positive to negative direction. Again, this will be plus, this will be minus. Again, this will be plus, this will be minus. If you consider current in clockwise direction, then you apply KVL. Apply KVL in this loop or mesh. Okay, loop, in anything you can say. So if you go in clockwise direction, the first thing you are encountering is this minus sign first. So minus 2 volt. Then you are encountering this plus sign first. So plus, and what is the voltage drop across this? Resistance multiplied by current. So 1 multiplied by I. Similarly, you are encountering this minus sign first. So minus 2Vx. Then you are encountering the plus sign first. So plus, and what is the voltage drop? Resistance multiplied by current. That is 1 multiplied by I. Okay. Then you are encountering this 2 ohm resistance, that is plus sign first. So plus 2I. That will be equal to 0. Now here you can see that there are two unknowns, Vx and I. So this is equation 1. There are two unknowns in equation 1. So that you cannot solve. You need another equation. So another equation will come from Vx. So Vx here is given as plus in this sign, minus in this sign. But according to the current sign that you have, or current direction that you have considered, this plus minus sign is in opposite direction. So you can write Vx is equal to minus of, Vx is equal to minus of the current that you have considered multiplied by the resistance. So Vx is equal to minus I. This is equation 2. So replacing equation 2 in equation 1, that means substituting 2 in 1, what you can say? Minus 2 plus 1I minus now Vx. Now Vx is your minus I. So if you replace Vx with minus I, this minus minus sign will be become plus. So 2I plus 1I plus 2I, that will be equal to 0. So from here 3 plus 3 6. So I will be equal to 2 by 6 or 1 by 3 ampere. Is it clear? Please let me know in the chat. Is the first thing clear that IB this, or and the current I is in same direction as IB. So you considering current source, your IB is equal to, only considering current source, is IB is equal to 1 by 3 ampere. Okay. Please let me know in the chat whether it is clear or not. Yeah. Okay. So means when I'm sharing the screen, I'm not being able to see your chat. That's why to see your chat, I have to like, okay, it's clear. Anyone, those who have not joined the previous class, you can always ask. Okay, I will take extra class. Those who joined late, I will take extra class this Sunday, most probably this Sunday. Or if you are like, if it works for you, that after like 6, after 6 also I can take. But I don't know whether it will be possible for you or not. Any day after 6, any in the weekday after 6, or in Sunday I can take. Those
फिजिकल रिपोर्टिंग के बाद ले लीजिएगा.
फिजिकल रिपोर्टिंग, अरे फिजिकल रिपोर्टिंग में और भी प्रॉब्लम होगा, क्योंकि क्लासरूम का प्रॉब्लम होगा ना. क्लासरूम में लॉक लगा होगा, उसका चाबी लो. यहाँ पे तो जस्ट ऑन किया और क्लास ले लिया. ठीक है, उसके बाद भी लेंगे, उसके बाद भी लेना पड़ेगा, क्योंकि ऑलरेडी टाइम हम लोग मिस किए हैं, तो अभी भी ले लेते. So that is for who joined late. Okay, they should tell, okay, it is not possible. Okay, so we have what we have done. We have considered only the voltage source. Now next we will consider the current source. for that we have to deactivate the voltage source. That means replace with the its internal resistance that is equal to 0. That means you have to short this. So the current source will be there. Then there will be this 1 ohm resistance. One ohm resistance. Then there will be, this will be sorted. So 2 ohm resistance. Dependent voltage source. One ohm resistance, and there is this IB. Now you have to find out what is the IB. Now what, in whatever way you find out, either use mesh analysis or loop analysis. Let us use mesh analysis. You can clearly see that are two mesh. This is mesh 1, this is mesh 1, this is mesh 2. So you have to consider a clockwise current. So in mesh 1 we are considering I1, in mesh 2 we are considering I2. Okay, so applying KVL in mesh 1. Applying KVL in mesh 1, we will get the first equation. So let us first write the polarities. So it's moving in this direction. So this will be plus, this will be minus, this will be plus, this will be minus, plus minus. So applying KVL, let us start from this 1 ohm resistance. You are encountering the plus sign first. So plus 1 multiplied by I1. Then you are encountering the minus sign first. So minus 2 Vx. Plus sign, plus 1 multiplied by I1, and again plus sign, so plus 2 I1, that will be equal to 0. So you are getting 4 I1 is equal to 2 Vx. So I1 is equal to Vx by 2. Okay, so this is applying KVL in, okay, here, sorry, I made the mistake. While writing this voltage across, you have to voltage across this 1 ohm resistance, you have to also consider I2. Okay, because to this part I1 is flowing, to this part I2 is flowing. So the net current across this 1 ohm resistance will be I1 minus I2. We are considering I1 is greater than I2. We are considering I1 is greater than I2. Okay, so both I1 and I2 will be there. That is 1 4 I1 minus I2, that will be equal to 2 Vx. Okay. Now Vx, what will be Vx? In the figure, Vx is given like this, plus, this is minus sign, this is plus sign. So considering this direction of I1, in the question the Vx is denoted like this. This is plus, this is minus, and it is denoted as Vx. So according to your convention, that whatever direction of current you have considered, in that case Vx will be equal to minus of I multiplied by I1. So Vx will be minus I1. Okay, so this is equation 1, this is equation 2, and then you apply KVL here. Okay, that means first let us denote the plus minus sign. So considering I2 is flowing in clockwise direction, and I2 is greater than I1, so this will be plus, this will be minus, plus minus. Okay, then if you apply KVL, what will be the value of current I2? There is already, if you remember one of the cases in mesh analysis, that when there is a current source you don't have to do anything. I2 will be just equal to the current source, but you have to see the direction. I2 is flowing in this direction, but the current source is in opposite direction. So minus sign will be there, minus 2. Okay. So if you just put these values, so this is the third equation. So replacing equation 3 and equation 2 in equation 1. Okay, then what you equation 1 will look like this: 4i1, I2 is minus 2. This minus minus sign will become plus, plus 2. And Vx is minus I1, so minus 2i1. Okay, so if this comes, this will be 6i1 minus 2, so I1 will be equal to minus 1 by 3 ampere. Okay, I2 is minus 2 ampere, and I2 is minus 2 ampere, and I1 is 1 minus 1 by 3 ampere. Okay, so now the net current, so this is your 1 ohm resistance. Okay, you have to find out what is the current flowing through this IB. Now I1 is flowing, you are getting minus 1 by 3, so you have considered clockwise direction, that means from top to bottom, but your minus sign is there, so that's why current will be flowing like this, that is 1 by 3 ampere. This is I1. I2 is also you have considered in clockwise direction, but here it is showing that it will be in anti-clockwise direction because minus sign is there, so it will be in this direction, and its value will be 2 ampere. So 2 minus 1 by 3, so IB will be equal to 2 minus 1 by 3. Okay, so 5 by 3 ampere. So IB, due to the current source, IB will be equal to 5 by 3 ampere. Due to the voltage source, IB was equal to 1 by 3 ampere. So the total current will be 5 by 3. IB will be equal to 5 by 3 plus 1 by 3. Okay, so 2 ampere. Is it clear? Is it clear? Okay. Next, so this was example of superposition theorem when there is a dependent voltage source. Next, an example of Norton's theorem, how to apply Norton's or Thevenin's anything, Norton's theorem with dependent source. This is bit different. Okay, let us consider a circuit. Again, a dependent voltage source, and is dependent on VD, means some kind of voltage it will be there. So voltage dependent voltage source, okay? Voltage controlled voltage source. 2.2 k ohm means kilo ohm. There is a current source. Again, dependent current source. Okay, and it is dependent on some kind of voltage VC, and it is 25 this. So this is the load resistance. If you are applying Norton's theorem, that means what you have to do, you have to represent the equivalent circuit. That means this circuit you have convert into a current source. In parallel, there will be a resistance, and here your load resistance will be there, RL. So this will be your Norton's equivalent current source. This is Norton's equivalent resistance, and that will be RL. Okay. So this circuit you will convert into this. So what are the steps? The first step, step 1. Or we can start with Thevenin's also. Let us first start with Thevenin's. How to apply Thevenin's theorem with a dependent source. That means the equivalent circuit will be like this. There will be this voltage source. This is the Thevenin's equivalent voltage, and there will be the resistance, that is RTH, and RL will be there. So the first step, let us start with Thevenin's because we have done the Thevenin's first. So let us start how to deal with Thevenin's theorem with dependent source. Okay. The first step, we have to remove the load resistance. And in Norton's, it was you have to replace the load with a short circuit. Okay. In Thevenin's, you have to replace the load with an open circuit. That means your circuit will look like this. The circuit will look like this. This is 5.6 kilo ohm. Okay. So VD, now here you need to know what is VD and VC. Okay. So VD is given like this. So plus minus VD, and VC is given like this one, plus minus VC. That means this voltage source, this dependent voltage source is dependent on the voltage across, means how it is given. Okay, this is VD. So 5 times of this VD, that will be this voltage source, dependent voltage source value. Okay, and this VC is given as the voltage across this 5.6 kilo ohm. Okay, 25 times of that VC, this will be the value of this current source. Okay, this is, again, this is 2.2 kilo ohm. This is 5 VD. VD is nothing but this, plus minus VD. And now here, plus minus VC, no current will flow through here because this is an open circuit. So no current will flow through this path. So VC will be equal to 0. That thing is clear. If no current flows through this 5.6 kilo ohm resistance, then VC will be equal to 0 because current I is equal to 0. That means this is equal to 5.6 kilo ohm multiplied by 0 current. That's why you are getting 0. So this 25 VC, this is of no use. This is of no use. But this voltage source will be there. Now, in the next step, what you have to do, you have to find out the voltage across these two terminals. Okay, this is your VTH. Now, no current is flowing through this path. No current is flowing through this path. So whatever the voltage is there, the same voltage will be in these two terminals. Okay, that is, you are consider this as VTH. If this is grounded, then this will be VTH, and these are also joined. Okay, so this is a single node. So you can apply KVL here. Okay, you can also apply, you can apply KCL here. You can also apply KVL, no issue, but let us apply KCL. That means or you can apply KVL also, because this will vanish. If this current source was there, then you apply KCL, but if this is not there, then you simply apply KVL. No issue. So the circuit will look like this. That means there is this voltage source, that means plus minus 5 of VD, okay, and then there is this 2.2 kilo ohm resistance, 2.2 kilo ohm resistance. The current source, your VC is becoming equal to 0. The moment you make this open circuit, the VC will be equal to 0. So this current source will be equal to 0. There will be 0 current flowing, and the internal resistance is infinite. So no current will pass through this path. No current will be passing through this path. And the current source is equal to 0. So you can consider it like this. Simply you can remove this part, and there is a 10 kilo ohm resistance. This is your plus minus VTH, and this is also your plus minus VD. Okay, plus minus VD. So you can apply KVL. So considering any clockwise current, so this will be plus, this will be minus, this will be plus, this will be minus. Considering clockwise current I. So you are facing this minus sign first, so minus of 5 VD. Then you are encountering the plus sign first, so plus 2.2, or in terms of like ohm, you can write it as, okay, this much ohm multiplied by current I. Again, considering encountering the plus sign first, so plus 10,000 multiplied by I1, that should be equal to 0. Now one equation, two unknowns. So now VD you can write in terms of this. VD is this one. So VD is equal to 10,000 and I, sorry, I1, it's I. This will be VD. Okay. If we apply here, minus 5 into 10,000 I plus 2200 I plus 10,000 I, this will be equal to 0. Whatever you do, if you add this and everything, whatever you will get, your I will be equal to 0. It is showing that your I will be equal to 0. By solving this equation, we are seeing that means something, some constant multiplied by I0. That is, you are equating with 0. That means I should be equal to 0. So this will be minus 50,000 I plus 2200 I plus 10,000 I. So minus something I will be there, that will be equal to 0. So your current that is flowing through this circuit, that will be equal to 0. If current is equal to 0, that means no voltage drop will be there. That means this voltage across these two terminals will be equal to 0. So here the VTH, or the Thevenin's equivalent voltage, Thevenin's equivalent voltage, that is VTH, that will be equal to 0 volt, because current that is flowing through the circuit is 0. Clear? Let me know in the chat. We'll see what will be the equivalent circuit later, but till this point, next step is finding the Thevenin's equivalent So here you will face some issues because you don't know what is the first step in Thevenin's equivalent resistance. Again, using this circuit, that means you have to deactivate the load resistance, then you have to deactivate the sources. But those were independent sources. You have to deactivate the independent sources. But these sources are dependent. So how will you deactivate them? So here the problem lies. That means your circuit will look like this. Your circuit looks like this. Now you have to look through these open terminals and you have to find that what is the resistance you are facing. The deactivation of the sources will not work because these are not your independent sources. These are dependent sources. And how will you deal with this? Do you know? Anyone know how to deal with this? Means you have seen some books and everything. So do you know how to deal with this kind of a circuit where you have to find the Thevenin's equivalent resistance, but there are dependent sources. So these type of problems is very important. Okay, that's why especially I am solving these problems. Anyone? Are you aware of this kind of a circuit? So to deal with this kind of a circuit, what you have to do, you have to find the resistance. Okay, you have to find the resistance value, RTH. Now, if you apply, let us say we are applying a current source here, current of 1 ampere. You can take other values also, no issue. But why? Let us see. Aim, please remember the aim. The aim was to find RTH. And according to Ohm's law, what we know, R is equal to V by I, V equal to IR, or resistance is equal to V by I, voltage by current. We are applying a current source. Based on that, whether if we find out what is this V, then the resistance will be equal to V by 1 because you are applying a current of 1 ampere. And based on that, you are getting a voltage of V. Definitely the current between these, resistance between these two terminals will be V by I. I is equal to 1 that you are applying and V will be, you should find. So due to this 1 ampere current source, what is the voltage you are getting across these two terminals? If you can find that, you'll be able to find out your RTH. This is nothing but RTH. For that, you have to find out what is this V due to this current source. Now, when you are applying current source, this VC, this VC is still active. Accordingly, this current source will be active. This VD will also be there, plus minus VD. That's why this will be also active. Now, based on that, you have to find out what will be this voltage. Now you are seeing that there are number of parallel paths. This is a parallel path. 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 So I have already told you when to apply nodal and mesh analysis. The thumb rule or the guiding rule you can consider is that if there are more number of parallel paths than in series, okay, more number of elements that are there in parallel than in series, you have to apply, you can apply nodal analysis. Okay. So if you consider this as a particular node, if you consider this as a particular node, this as, let us say, ground, then how to write the KCL equation? Let us say this is node 1. So KCL equation at node 1. So to apply KCL, you have to consider some voltage here, unknown voltage. Okay. That voltage you can consider, let us say V1. Let us say consider V1. V1 we don't know what its value. Okay. So applying KCL, consider this branch first. Okay. So V1 minus of 5 VD, that you are applying across this 2.2 kilo ohm resistance. So on one side, on this side of the resistance, you are applying V1 that you don't know. On this side of the resistance, you are applying 5 VD. So minus 5 VD divided by the resistance value. This one. This will be the current. This will be the current that is flowing through this 2.2 kilo ohm resistance. But you don't know V1, you don't know VD. Okay. But I have already told you that consider this node to be at highest potential value. Okay. So this is plus sign, because if you consider this node to be at higher potential, then current will flow in this direction. And current is going out. Current is going out of this node. So plus sign is there. Next, consider this branch. Current is going in, and what is value? 25 VC plus, sorry, minus